Hello, good afternoon, and good morning for some people in US. I know that some people are present, so yeah, and I hope you are fine. Yeah, we will start in 2 minutes because I can see the number of attendees growing. So we will start in 2 minutes. Hello, good afternoon, good morning for some people in US. We will start in 1 minute now. Hello, good afternoon. We will start in 1 minute now. We are ready. We are ready.
Hello.
Hello. Hello, good afternoon. So, okay, I think that we can start. Hello, good afternoon all, and I hope you are fine and ready for this interesting webinar. So, I'm Didier Sampere, working in the global marketing Avantor organization to push and promote chemicals and chromatography products. And I'm sure you will agree with me that water determination by Karl Fischer method is certainly one of the most common methods used in the analytical labs for many different substances. But to perform in this complex method, you need to avoid some mistakes. And today we will present a webinar called How to Perform Successful Karl Fischer Titration in Diverse Products. This presentation will be made by Dr. Roman Neufeld from Honeywell, and thank you very much in advance. He will explain how the Karl Fischer application can be adjusted based on the sample properties to avoid misleading results. He will also give us many tips and tricks to perform on this analytical method and avoid some errors. So I'm sure and convinced that this webinar will be very helpful for you. And after that, I'm sure that you will be more comfortable to avoid issues with your different samples. So this webinar will be recorded and you will receive the recording after the webinar. You can use the window question to ask some questions, and we will take these questions after on the Q&A session. And after that, I think that I can wish you a great session, a great webinar. So now, Roman, up to you.
Okay, thank you, Didier, for the kind introduction and for inviting me to present this special Karl Fischer webinar. I hope it will be valuable and inspiring for the audience. And as you said, my name is Roman Neufeld, and I'm a senior research scientist at Honeywell. And I'm with Honeywell since 7 years now, and my job is to develop and further improve our hydrogenol Karl Fischer products. And furthermore, I provide technical support and application development to our hydrogenol customers worldwide. Today I have the honor to share my knowledge about Karl Fischer titration with you. And I would like to start my presentation with a short introduction about Karl Fischer titration. And then I will give you some tips and tricks which may help you to get better titration performance. And after that, I will continue with the troubleshooting, where I will highlight some potential errors across the industry sectors: pharma, food and beverage, petrochemical, and lithium battery industry. And finally, at the end of the presentation, you will have the opportunity to ask me some questions. Okay, let's start the presentation with a question: why is water determination so important, and many people are not aware of it, but the water content determination is critical across all industries, and it has a direct effect to our daily lives. So if you have, for example, too much water in kerosene, it can lead to crystallization in the turbines and potentially causing the jet to crash. So this would be very bad. And if you have too much water inside plastics or food, chemicals and APIs, then you will have a negative impact on the product quality, shelf life, and functionality. So this is why it is very important to perform accurate water determination across all industries. And yeah, the most valuable titration method for accurate titrations, accurate and reliable water determinations is the Karl Fischer titration. The Karl Fischer titration relies on the reaction of water with iodine in the presence of SO2. And the interesting thing is that if you mix water with iodine, then no reaction will happen. And if you mix iodine with SO2, there will also be no reaction. And only if you mix all three compounds together, then the brown iodine solution will react selectively with water and SO2 to give colorless sulfuric and hydroiodic acid. And typical volumetric titration is performed by adding an iodine SO2 solution, the so-called titrant, um, to a closed beaker which contains the sample dissolved in methanol. And when the iodine solution is mixed together with the sample, the brown iodine will react with the water of the sample and will decolorize. And at the end point of the titration, where all of the water has been consumed, the iodine is not reacting any further, and the solution becomes brownish, and due to the formation of excess iodine. And um, then you know, okay, this is the end point of the titration, and by using the consumption of the iodine solution as reference, you can then calculate the content of or the water content of the sample that was dissolved in the vessel. So it's very simple mechanism, the way I described it here, but in reality, it's of course a little bit much more complicated because several equilibria are involved in the reaction, and it is also important to have a well-working base inside the reaction to be able to buffer the acids that are produced during the reaction. And without a base, the Karl Fischer reaction would come to a fast end and would provide wrong results. And this is why our hydrogen reagents use imidazole and imidazole derivatives to achieve a well-buffered reagent and to guarantee highly accurate results. Yeah, the KF titration can be differentiated between two basic forms. On the one hand, you have the volumetric KF titration, where the volume of the reagent is used as reference for water content calculation, as shown in the slide before. And on the other hand, you have the coulometric KF titration, where the iodine is produced electrochemically directly in the reaction chamber. And the volumetric KF titration is typically used for samples with water contents, let's say more than 100 ppm up to 100% water, whereby the coulometric KF titration is highly sensitive towards very small amounts of water and can measure up to water content down to 1 ppm. And finally, a special form of titration is to combine the volumetric or coulometric titration cell with an oven where the sample is heated up in a vial, and only the evaporated water is then transferred into the titration cell and where it gets titrated. And this method is often used for solid samples or samples that show a side reaction when they are added directly into the titration cell. This way you can avoid side reactions. You may already know that the volumetric KF titration can be divided into two different titration systems. So on the one hand, there is the one component system, and on the other hand, component system. In the two component titration system, all reactive compounds like iodine, SO2, and base, they are separated into two different bottles. The first bottle, the titrating agent, contains only the iodine in alcoholic solution, and the working medium, the so-called solvents, they offer the SO2 and the base. And the Karl Fischer reaction can only take place if both solutions are combined together in the titration cell. In the one component system, this is different. Here, all reactive compounds are combined together in one bottle. These are the so-called composite reagents. And this has the benefit that you are very flexible with choosing your working medium. Here you can use different types of methanolic solvents, pure methanol, but also methanol-free solvents like our K-type reagents, which can be used for the titration of methanol-sensitive samples like ketones and aldehydes. And this would not be possible, for example, with the two-component reagents. However, also the two-component reagents have some benefits. They are extremely stable since the iodine is separated from the reactive compounds like SO2 and base, and the pH value is higher, so the titration speed is very fast. And due to the presence of high SO2 and base concentrations in the solvent, the working media have a higher buffer capacity for bases and acids compared to normal methanol dry, for example. And finally, we offer CMR-free versions of the two-component reagents, which are free of carcinogenic, mutagenic, and reprotoxic compounds. Okay, coming back to the coulometric KF titration, here we distinguish the cell with and without diaphragm. The cell without diaphragm is very convenient to use since you have only one reagent that acts as analyte and catholyte. And furthermore, the titration cell and generator electrode, they are easy to clean. And on the other hand, you have the cell with diaphragm, which is generally more accurate, especially for the titration of samples which have less than 50 ppm water. And it is also recommended to be used for KF reagents that contain solubilizer like chloroform, xylene, and long-chain alcohols. And these reagents, as mentioned here, they can also be used in the cell without diaphragm. However, you have to keep in mind that the titration results will be systematically increased by 3 to 8%, or in other words, you will measure instead of 100 ppm, the result will be 1000 ppm, the result will be 1030 or up to 1080 ppm, in the range somewhere between that. And this depends on the used reagent and the used titration equipment. So it is possible to use these reagents in a cell without diaphragm, but you have to keep in mind that the results will be increased. I hope this general overview was helpful to refresh your knowledge about the KF titration methodology. Now I would like to go a little bit deeper into the KF topic and to give you some valuable tips and tricks so you can further improve your KF titration experience. And one of the most frequently asked questions is how to proper store hydrogenol reagents. And the easiest way to find first information is, of course, reading the safety data sheet. So in most SDS documents, it is written that reagents need to be stored in a place which is dark, dry, and where the temperature is below 35 degrees Celsius. Furthermore, we recommend to place not only the reagents but also the KF titration vessel away from direct sunlight. And this will avoid strong temperature changes during the application and therefore also reduce the tighter decrease of the KF reagents. And finally, you will also avoid an accelerated decomposition of the reagents. While pure alcoholic iodine solutions like, for example, our two-component reagent hydronol titron 5, they are very stable. However, complex compositions like the one-component reagents, for example, hydronol composite 5, they show a weak self-decomposition, which is normal. However, at temperatures below 35 degrees Celsius, the maximum titer decline is around 0.1% per week, which is really not very much. And which other external parameters have an influence on the titer stability? And of course, the air humidity plays a dominant role for the titer stability. You have to imagine that only 1 liter of air contains an average 12 to 15 milligram of water, and therefore the reagents need to be protected against external humidity by using drying agents like molecular sieves in the drying tubes. And furthermore, temperature has also an influence on the titer value, because the titer value is given as a function of a volume, so it's given in milligram per milliliter. So if it's getting warmer, then also the volume of the reagent will change, and in consequence, the temperature, let's say a temperature increase of 1 degree Celsius results in a titer decrease of approximately 0.1%. And with small temperature changes, it's not so dramatically, but if the temperature is changing very strongly during the work time, let's say by 20 degrees Celsius, then the effect will be significant. So at lab environment that has a controlled air conditioner that provides very stable temperature and humidity levels, it might be okay to perform a titer determination once a week. However, most labs perform a titer determination once a day, since often the lab environment changes every day, and some even do the titer determination more than once a day if temperature is changing, for example, by 10 degrees Celsius. And we recommend performing at least a triple determination, so that allows the elimination of any possible outliers. The very best results are, of course, obtained if you perform a 5-fold or even higher determination number. And patients in the second decimal place are normal. So a relative standard deviation of smaller than 0.2% is really achievable. However, if you have an RSD that is above 0.4%, then there might be some external influence which has to be resolved. To get best results on the titer determination, I have summarized our recommended procedure as following. So before connecting the hydronol composite or titrant bottle to the titrator, we recommend to shake the bottle gently to homogenize the reagent inside the bottle. Then rinse the burette and, of course, the transfer tubes of the equipment with an automatic rinsing program. So we recommend to do that at least 3 times. And then clean the platinum pins of the indication electrode with a soft paper tissue. So you can also rub the platinum pins to get rid of any kind of deposits. And Then you can fill the titration cell with a solvent like methanol dry and start the conditioning mode and wait for a stable drift that should be below 20 microgram per minute. And when you have achieved the stable drift, then you can start the titer determination by using, for example, hydrogen water standard 10.0. Yep. So for the titer determination with liquid water standards, we recommend using gas-tight glass syringes with long and thin needles. And here at our hydrogen lab and also in my application lab, we use those of Hamilton, but you can also use other brands. It is also possible to use fresh plastic syringes, but then it is recommended to work more quickly, since keep in mind that plastic syringes, they can still breathe, so external water can go inside the syringe, and this will change the water content over time. And whereas if you use these gas-tight glass syringes, then the water standard can be used for several hours, sometimes even for one day, because it's then very protected inside the glass syringe. And at this point, I would like to say that this red number at the upper corner, that's a hint to a technical document or a lab report, which can be downloaded from our website. So please note that you can find a link to all relevant documents that I'm referring here in this presentation in the download section of this webinar platform. Okay, so at this point, I would like to show you how we recommend to handle our liquid water standards correctly. So now we have the webcam. I can also show you something. So let me check. So in general, this protocol can also be used to all liquid samples, so not only for water standards, but I will show it to you with our water standards. So the first step is to homogenize your sample inside the beaker or the water standard inside the ampule. Then snap. Oh, I have also some glasses. That's good. It's always good, of course, to wear protective equipment, and that's important. So please shake your sample, then open the ampule, and first step is to take just a little bit, let's say open 5 milliliter of the water standard or your sample into the syringe, and then to dispose the rest without taking any air into the syringe. So this way we rinse the inner side of the syringe and the plunger, and then wipe the needle dry and take immediately the rest of the water standard into the syringe. And we recommend to leave just a few drops inside the ampule to make sure that it's not getting wet from external humidity, and wipe the needle dry again and avoid taking any further air into the syringe. However, you will always have a small bubble which comes from the dead volume of the needle in the syringe, and I use it to homogenize the water standard inside the syringe by moving the syringe a little bit. And at the last step, you have to remove the bubble and wipe the needle dry, and then the water standard has been transferred perfectly into the syringe, and can be then used for title determination or validation process. Okay, for this we have also a T report that you can download. Good. Let's move forward with the presentation. I would like to discuss the next topic will be the troubleshooting and how to avoid errors during the KF titration. And I hope that the following slides will provide some valuable information.
It's okay, Roman. It's okay. No problem. It's okay. We can see the slide. It's okay.
Okay, good. So, I would like to show you some tips and tricks to avoid errors during your KF titration, so you do not fall on your head like this little turtle. And I would like to start with error number 1, which is side reactions with ketones and aldehydes. And ketones and aldehydes, most of you I think know it already, they react with methanol to ketones and acetals, whereby water is released as a byproduct. And this side reaction causes too high water content results, and also sometimes no titration points reachable. And additionally to that, aldehydes can undergo a bisulfate reaction, which traps water in a complex that releases the water very slowly, and that results typically in decreased water content. However, most of these side reactions can be suppressed by using methanol-free. We call them K-type reagents, such as composite 5K and medium K for the volumetric titration. And for the coulometric titrations, you can use either Coulomat AK with CGK or our newly developed alcohol-free reagents like hydrogenol Coulomat AFA and CFA, whereby the new reagents have a higher capacity and provide even more accurate results for the titration of ketones. I would highly recommend that. As an example for the pharma industry, I've picked the titration of acetone. And if you titrate acetone and methanol, you will have a huge water releasing side reaction with no endpoint, as you can see from the red curve. And if you perform the titration with methanol-free hydrogenol medium K, then a stable titration endpoint is achieved. So for those who are interested, we have performed a suitability test in accordance to the Pharm OIA, which can be downloaded from our website. And for the those from the food industry, they may be interested in methanol-free reagents and some famous aroma additives like that of almonds are made of aldehydes. And also here if you're interested in the titration of aldehydes, I will recommend checking our lab report number 676. For the petrochemical products like oils, they are typically free of ketones and aldehydes. However, it is known that petroleum and biodiesel, they can contain small amount of ketones, which provide increased titration results. So if you perform KF titrations of petroleum on biodiesel, then it might be advantageous to check if the titration in methanol-free reagents give other results and more accurate results, especially. In the lithium-ion battery industry, ketones and aldehydes are very uncommon. However, I have seen already some R&D efforts to use natural derived ketones as sustainable alternatives for carbonates. And in this case, for the titration of electrolytes that contain ketones, I would highly recommend to use our new alcohol-free AFA and CFA reagents. Besides side reactions, the most common error that is present across all industries is the dissolution problem. If the sample it does not dissolve correctly in the KF medium, it may cover the platinum pins of the indication electrode, which can cause indication problems, and this will result in no or delayed endpoints. Furthermore, the water may not be extracted completely, which will provide underdetermined results. And last but not least, bad solubility may increase the titration times, which is additionally increasing the overall error. And to solve the solution problems, you could either use a homogenizer or you can increase the temperature. This is also often very helpful. Additionally, you can also add solubilizer to the working medium. And here, for example, 1-hexanol, chloroform, and xylene, they are very helpful to increase the solubility of non-polar samples. And on the other hand, you can use formamide dry as very for polar samples like salts, sugars, and proteins. You could either prepare these solutions manually by mixing them freshly in the titration cell, or you can save a lot of time by using our ready-to-use premixed solvents and reagents for non-polar samples. So we offer different premixed solvents for the one component and the two component system, and also special colorimetric array reagents for most accurate titration of non-polar samples, such as, just to give some examples, vegetable oils or CBD oil is now very popular, and different kind of oils like crude oil as well. And for dissolution error problems, I have again collected some examples across all industries, and here is an example for the pharmaceutical industries where the suitability test of gentamicin sulfate has failed with the standard titration methanol dry. However, as shown here on the right-hand side, the addition of formamide helps to dissolve the sample, and then the farm oil suitability test can be passed accordingly. A classical sample in the food industry is the KF titration of milk and white chocolate. So I love chocolate, so I have no solubility problems with chocolate. However, for proper KF titration, the addition of chloroform or the titration at 50 degrees Celsius is required to dissolve, especially the non-polar fats. And furthermore, we found out that for white chocolate, it is even necessary to add formamide, not only chloroform, but also fluoramide to dissolve the high sugar content of the white chocolate, which otherwise will not dissolve in normal methanol. If we look at the petrochemical industry, then for most users in that industry, it is very well known that solubilizers like chloroform are required to improve the solubility of oil samples, or at least enhance the water extraction from the emulsion that is formed during the titration. And for crude oil, it is even required adding xylene to the titration medium to increase the dissolution of other components like tar. And for the volumetric KF titration, we offer hydrogenol solver crude oil, and for the coulometric titration, hydrogenol coulomat oil. which both contain chloroform and xylene as solubilizer, and which can be used as a ready-to-use reagent in accordance to several ASTM methods, like ASTM 4377 and 4928. Yeah, and for the lithium battery industry, solubility issues are also known, especially if lithium-ion electrolytes um, are titrated. So these contain often very high concentrations of polar lithium salts, which can easily precipitate and then cause indication problems. And especially with our new alcohol-free reagents, AFA and CFA, the solubility of some lithium salts are limited. However, we found out that the addition of N-methylformamide, NMF, to the analyte can increase the overall solubility of many LIB salts by a factor of 5x. So for anyone who is or everyone who is using our FA reagents, I would highly recommend to use NMF as solubilizer, to improve the performance of the titration and also to reduce overall costs. And if someone is interested in that application, feel free to contact me, then I can share further information about that. Yeah, last area I would like to talk about is about the influence of acids and bases, which are known to be problematic for proper Karl Fischer titration as well, since they can cause an iodine consuming site reactions, which will result in no or delayed endpoints and indication problems. Finally, acids can decrease the pH value of the Karl Fischer medium to that point that the Karl Fischer reaction will stop and the obtained result will be too low. Many of these problems can be overcome by adding manually special buffer materials to the Karl Fischer working medium. And you can use, for example, imidazole to neutralize the impact of acids, or use benzoic or salicylic acid to buffer basic samples like amines. And the good thing is that for the volumetric KF titration, we offer ready-to-use working media that can be used directly as working medium. And for the titration of acids, you can use hydrogenol buffer for acids, and for the titration of amines, for example, hydrogenol buffer for bases is very well suited. Both working media can be used together with the one component reagents such as composite 5. Yeah, and again, I will show some examples across some industries where pH related problems occur. And for the pharma sector, I have selected here the titration of vigabatrin, which fails the OIA suitability test if the titration is performed with normal methanol. However, if the titration is done with hydrogenol buffer for bases, results are good and the test passes. For the food industry, I found an additive that is typically used for tonic water, which I drink also, which I like to drink. And that contains a highly basic compound, which is quinine. And for the titration of tonic water or even pure quinine, we would recommend using hydrogenol buffer for bases to get accurate results. And just for the sake of completeness, I have also shown here that the coulometric titration of tonic water would, of course, not be recommended due to the very high water content of the soft drink. So that only the volumetric titration would make sense in this case. The petrochemical industry, they apply often amines as additives for lubricating oils, engine fuels, and asphalt, just to give some examples. And if you see that one of your oil sample contain amines, then we would also recommend to use a mixture of buffer for bases with chloroform, a solubilizer, and in case of the coulometric titration, you can use coulomat oil with 20 gram of benzoic acid to minimize the impact of the amines. Yeah, last but not least, I wanted to show the negative impact of borates like LiBOB, that is typically used as an additive or as a main lithium salt for lithium battery electrolytes. And this reacts with all kinds of alcohols to yield lithium oxalate, boric ester, and water. And in normal alcoholic Karl Fischer reagents, this reaction is very fast and very prominent. So sometimes you will even get a beautiful, stable endpoint, like it is observed on the red curve, titration curve. However, the result will be totally wrong. So instead of measuring 20 ppm, you will measure 1000 or even 3000 ppm, depending on the LIB concentration. And the good news is that by using our alcohol-free reagents, coulomat AFA and CFA, the reaction is completely avoided due to the lack of alcohols, and you will get a nice titration with accurate result of 20 ppm. All right. Yeah, I would like to finish my presentation by inviting you to visit our website, lab.honeywell.com. If you navigate to resources and then to resource library, you will find a lot of helpful information like our product overview, but also lab reports for more than 800 different samples, and also ready to use farm oil suitability tests for more than 60 compounds. And yeah, Didier, I think, we agreed that we will make some materials also available on your VWR website, but this will take some time, right?
Okay,
Okay.
thank you, Roman. Thank you very much.
Point.
Thank you very much. It
Yeah,
was,
thank you.
yeah, go.
Thank you very much.
Yeah. No, I think it was really complete, and I learned a lot. I appreciated a lot your tips and tricks and your recommendations to avoid some serious issues. I think it was really important and helpful. And another point, it's the first time I could see an experience directly during the webinar. So I think it was a good experience, and I am sure it will be really helpful. So now we can start the Q&A session
Sure.
because
Yeah,
I
thank you.
received some questions, and I will start. So, question. Yeah, the first question from Germany. What are the differences between normal reagents and special oven reagents?
Yeah, we offer, and I think with normal reagent, it's meant our normal coulometric reagent, which is coulomat AG, which is methanolic, and we offer for the oven application a special AG version, which calls coulomat AG oven, which is dedicated for the titration or for the application with a KF oven. And the difference is that the KF oven version, in that some part of the volatile methanol has been replaced by propylene glycol, which has a lower vapor pressure. So it has a better performance when hot gas of the oven is introduced into the reagent. So you will have a more stable drift if you use coulomat AG oven in the oven application, and you will have also less solvent evaporation during the process. So you will have to exchange the reagent less frequently and can also reduce some costs. So this is the main difference between the normal Coulomat AG and the Coulomat AG oven.
Okay, thank you, Roman. Another question. How do we know that the Coulomat AG needs to be replaced?
Yeah, good question. And directly see it from the color of the reagent. So if it's changing the color to some to brown or to colorless or even pink or something like or green, I don't know what can happen. So then you can see directly that something is problematic and not normal. However, sometimes you cannot see anything. Everything looks good. And the only way to find out if the reagent is working or not is to introduce water standards. So for the coulometric titration cell, you can use, for example, hydrogenal water standard 1.0, and where you know, okay, this has 1000 ppm, and you can titrate 1 milliliter, and if you find 1000 ppm, then everything is good, and you know that the reagent and the titrator is working properly. However, if the recovery is let's say lower than plus minus 2.5%, so if you find 1050 ppm, then this is a 5% error, then you know, okay, something is wrong with the performance, and then we would recommend to replace the reagent. So the farm oil is recommending to replace the reagents if the error is higher than plus minus 2.5%. So if then this would mean for 1000 ppm standard that recovery between 975 to 1025 would be okay, and everything that is outside this range is not okay. I
Okay,
hope
thank
that
you. Yeah.
helps you understand.
Yeah. Okay, another question. How to determine the minimum sample amount that has to be used?
The minimum sample amount, yeah, it depends on which method is used. For example, if it is the volumetric titration or the coulometric. So for the coulometric titration, it is more easy to answer because here we typically recommend using 1 milliliter. And for difficult samples like ketones and aldehydes, it is helpful to reduce the sample size to 0.5 milliliter. Sorry. And in case of the volumetric titration, we recommend to use a sample size which causes the need of the reagent that requires a volume that is between 10 to 90% of the burette volume. So you have the highest accuracy of the titration, of the volumetric titration, if the reagent consumption is between 10 and 90% of the volume of your burette. So the biggest error is if you have very small sample size and the reagent, the titrant consumption is only 0.01 milliliter, then the accuracy of the burette is very small, and you will have a big error, dosing error, so to say. And if you have, let's say, a 5 milliliter burette, then it's always recommended to have a consumption of 1 to 4 milliliter of reagent. So adjust your sample size to be between 10 and 90% of the volume of your burette.
Okay, Roman, we have time, but I have another interesting question. So, what will be your advice on that? What is the best way to clean a generator electrode? Do you have an opinion on that?
Generator electrode, we recommend to, it depends on if you have a generator electrode with or without diaphragm. Let's start with the version without diaphragm. Here, the first step is always to clean with an alcohol. So take out of your titration cell and rinse it with alcohol. And in the next step, you can also use pure water because water is also a very good solubilizer. And if you have titrated, for example, oily samples which do not dissolve well in water and alcohol, then it might be required to use chloroform or um, acetic acid. No, it's not. So let's say as a solvent which dissolves oil, not the acid. Sorry, it's I know the German word, but anyway, so you can use chloroform,
No,
for
no
example.
problem. Yeah, Roman. No, after we can bring
And
the answers later because yeah, okay, it's not an issue,
yeah,
but because we can send an answer to the attendees and we can bring the answers. So don't worry. But yeah,
okay, no problem.
okay.
And but in the end, please let me say only one sentence more. So in the end, it's always important to clean everything with a
Yeah,
volatile alcohol, so that can evaporate quickly, and this will also remove remaining water. So I would never would recommend to clean the generator electrode only with water and to leave it like that. So and but for the generator electrode with diaphragm, I would only use alcohol, so no water at all, because then the water will be trapped in the diaphragm, and then you will get a lot of yeah problems during the conditioning mode. And anyway, it's always beneficial to place the generator electrode with diaphragm also in the oven at 50 degrees Celsius for at least 30 minutes. Um, and then you will also get rid of any water residues in the diaphragm, and then you will have the very best titration experience if you use the generator electrode which has been dried in the oven.
yeah. Thank you. I have another interesting question concerning the standard, and I'm pretty sure that I know the answer. The question is, can water standard be replaced by water for injection?
By water, yeah.
No, I think that's
I
the
know there
law
are
of the
still
standard.
custom.
Yeah, exactly. Yeah, yeah. Go, go.
Yeah, I know that some customers try to use pure water, but um, they they know that they will have a huge error, and some can live with that. But most of customers they want to have very accurate results, and this is only achievable if you use diluted water in form of water standards, where you have a very big sample size and weight. So you do 5 milligram of water, but you weight water standard, which has 5 milligram water in it. So the weighing error is much lower. And let's imagine if you use pure water and you lose due to handling 1 milligram of your 5 milligram sample, then the error is dramatically. But if you use, I don't know, 5 milligram of 1,000 milligram sample size, then this will not be so critical at all. So you will always have the highest accuracy if you use water standards instead of using pure water.
Yeah,
Yeah.
yeah. Thank you, Orman. I've seen many questions, and we will bring the answers later. But the last one could be: is hydranal colomate AFA and CFA free of imidazole?
Yeah, these new reagents, they are indeed free of imidazole, so they are free in general of CMR substances, compared to Coulomat AK, which contains imidazole and chloroform. So everybody who is using AK might think to switch to the AFA reagents to increase, the safety. And these reagents are free of chloroform and free of CMR substances and give even better results. So there are a lot of arguments why to choose the new FA reagents and not the Coulomat AK, for example.
Okay, thank you. So we have also other questions, but yeah, I will send you the questions and we will bring the answers later to the participants. So I think that we're very close to the end. So I would like to repeat that concerning the brochures in our website Avantor, you have in literature part a session with chemicals and reagents, and you can write Honeywell and you will find many brochures. Of course, the main brochure concerning Karl Fischer reagents, but you have also other brochures. You have also a brochure tips and tricks. So you have many other brochures. You can also download directly the list of documents, because Roman has showed you some recommendations with a special number, and you will see the list of these documents. You will find also the main brochure concerning the Karl Fischer reagents. So you can download in the banner, you have materials part, and you can find the brochures and you can download immediately. And after some information. So tomorrow you will receive the recording. So feel free to share this recording with your colleague or with your team, because I'm pretty sure that this webinar can be used to inform your friends or your colleagues. In 1 week, you will receive a follow-up mail with many additional informations, with the links to the product range, to the brochures, to some application notes on the new product, for example. And after that, just after the webinar, 1 minute after, you will receive a survey. And honestly, I think that it could be great to receive your opinion, your feedback on this webinar, because we want to read your opinion for the future webinars, to find new ideas or new suggestions, or to improve the way to present a new product, new ranges, a new method, or some tips and tricks to perform on some analytical methods. Okay, so I think that it was very important to give you this information. So now I think that we can close the webinar. Thank you again, Roman. It was really great. I'm sure really helpful for you. And after that, I would like to wish you a great evening, and feel free to share this webinar, because I think it was a great webinar. Thank you very much for your attention and your participation.
Thank you all.
And thank you again, Roman, for
Appreciate.
this great webinar. Thank you.
Okay.
Bye-bye.
Thank you. Bye-bye.
Bye.